What's up? What's up? Mr. O here, and today we're going to learn how to construct unit circle and to be able to solve the trigonometric ratio and using the unit circle. Okay, but before we start, unit circle in mathematics is a circle with radius of 1, wherein that circle is in Cartesian plane or in the x and y plane. So imagine there's a circle, the radius, the center is in the origin, and the radius are all equal to 1. Okay, so we have learned already the measuring of the angles in degrees and in radian. And there are also topic that we should have learned about unit circle, like special right triangle, the 30, 60, 90, 45, 45, 90. But we'll try to make it easy. And some are just going to be defined to you. Okay, so let's start now. We all know that the unit circle, if it goes counterclockwise, is going to be positive. Okay, we're gonna assume that our unit circle will be positive. Okay, so that our basic, basic, because most of the answer will be asked from 0 to 360 degrees or the positive value. Okay, so let's start now. So this one here is the starting of our. Hold on. With the pencil. All right, so let's do first the degrees. Okay, so we know this is 0 degrees, right? 0 degrees, and then this is a whole pi or a whole or half of the unit circle. So this is 180 degrees. We know half of 0 to 180 is 90 degrees, right? And then if we do so if you notice, every quarter of a circle is 90, and 90 again, that's why it's 180. Then another 90, it will give us 270 degrees. Then another 90 there will give us 360 degrees. So that's why a full revolution is 360 degrees. And the 0 and 360 are on the same side, terminal side, on the positive x-axis. Okay, so then we know that half of 0 and 90 will be right here in the middle. That will be 45, right? So if you notice, I will keep on. Here's the pattern: 0, skip 45, then skip 45 will be 90, then 90 plus skip 45. 90 plus 45 is 135, so this will be 135 degrees. Skip plus 45, if you add 45 to 135, it will be 180. Skip plus 45 again, so 180 plus 45, it's going to be 225. Skip plus 45 is 270, so 270 plus 45 will give you the skip and that, which is 315 degrees. And when you add 45 to 315, skip and add it, will be 360, right? Excuse me. There you go. All right, that's the first one. The next one here, we know that the next portion there will be using the 30, 60, 90 triangle theorem. The smallest angle on the special angle will be 30. So you're gonna keep on adding 30 here. 30, skip 30. 30 plus 30 is 60. Plus 30 here, but this time you don't skip it. 30 plus 60 will be 90. 90 plus 30 is 120. 120, skip, you add 30 to the 120 is 150. And add 30 to the 150 is 180. Then you add again another 30 to 180 is 210. Skip it. Add 30 to 110 is 240. Add 30 again will give you 270. Add 30 to 270 is 310 degrees. Skip. Oh, I'm wrong. It should be over here. Should be 315 here. Skip. Add 30 to 310 is 304. 300. We add 30, it will be 340. We missed somewhere. Oh, this should be, sorry, it's already 12. Meaning this should be 300 plus 30 there will be 330 degrees. And then add 30 again will be 360. And that's the complete degree angle measurement in a unit circle. Now, let's do the radian. For the radian, you know that this is a 0 pi, a full pi, or a half revolution is just going to be pi, and half of the pi is pi over 2. Okay? And then, so every time, there's multiple ways to do this one, okay? So again, that's a pi, and a 3/4 or a pi and a half. This will be 3 pi over 2. And then a full revolution is a pi and another pi. So how many pi is there? 2 pi. That's why 3 halves here is 1.5. This is 2. So half, full, 1 1/2, and 2 pi's. Okay? Now, again, these are divided into 6. Okay? Again, if this, I'm gonna show you the pattern. Okay? Follow the fraction. Okay? And you will reduce the lowest term. When I say reduce the lowest term, let's say if I have 2 over 6, 2 over 6 is going to be 1 over 3, right? So that's going to be, if I have 2 pi over 6, the answer will be 1 pi over 3, or just pi over 3. ¿Entiendes? Okay. So this is really a triangle, a 30, 60, 90 there. But this angle here will measure, the first one is, it's going to be added by 1 over 6. You know, let me do it over here. You're going to do 1 over 6. Then if you add another 1 over 6 here, will be 2 over 6. If you add another 1 over 6 here, will be 3 over 6. If you're going to add 1 over 6 here, will be 4 over 6, and so on and so forth. Okay? So your fraction, I'll try to make it slowly, but it's just going to be a fraction here. Okay? So let's go ahead now. So this will be 1 pi over 6. So the next one, you're going to skip this. You're going to go here because you're going to add 30. You're going to have 1 pi over 6. The 1/6 will be 2 pi over 6. Okay, but what's 2 over 6? 2 over 6 is what? 1/3. So I'm going to erase the 2 over 6 and make this one as pi over 3 because it's 1. There's invisible 1 there. Okay, I can put the 1 there. Then add another pi over 6. So 2 pi over 6. This will be the 3 pi over 6. But what is 3 over 6? 3 over 6 is 1/2. So I'm going to write here pi over 2, or 1/2. So 3 pi over 6. Then this will be 4 pi over 6. But what is 4 pi over 6, guys? 4 over 6 is can be reduced to 2 pi over 3. Okay? If that's 4, skip 5. This will be 5 pi over 6. Okay? So after 5, it will be 6. What is 6 pi over 6? 6 pi over 6, the 6 will cancel. So the answer is just going to be pi. Then after 6 will be 7 pi over 6. Okay? Since you're going to skip that one, you're going to add another pi over 6 there. What's next after 7 pi over 6? If you say 8 pi over 6, you're right. But what's the reduced lowest term of 8 pi over 6? It's going to be 4 pi over 3. Then if you add another pi over 6 to the 8, it will be 9. What's 9 pi over 6? 9 pi over 6 can be reduced to, they're both divisible by 3. It's going to be 3 halves, or 3 pi over 2. Then add another one, it will be 10 pi over 6. What's 10 pi over 6? 10 divided by 6 can be reduced to 5 over 3. 5 pi over 3. And then skip, then go to the next one. 10 will be 11 pi over 6. You cannot reduce that one. And then the next one here, if you add another pi over 6 to the 11, 11 plus 1 will be 12. 12 divided by 6 is 2 pi. Clear? Now, that's the pattern, okay? Then, let's go to the middle. The one between 0 pi and pi over 2, that's 1/2, right? If that's 0, 1/2, the middle of half, the middle of 50 cents is quarter. It's 0.25. A 0.25 is a quarter. A quarter is 1/4. So this is pi over 4. Okay? If you notice, that's over 4. Okay? Look at this one here on the other side. So you add a quarter, it becomes half. You add another quarter to the 50 cents, so the 1/2 will be 75. 75 is 3/4. 0.75 is 3/4. So that's going to be 3 pi over 4. Then add another quarter to the 3/4. It will jump here. It will give you a 1 whole or a dollar or a pi. Okay, so you keep on adding a quarter here. But look at the technique. The middle portion is always over 4. Okay, so if that's 3 pi over 4, 4 over 4, 5 over 4, 6 over 4. 6 over 4 is same thing as 3/2 because 6 over 4, both divisible by 2 becomes 3/2. Then 6 over 4 is 7 over 4. See the pattern? And then you add another pi over 4 to the 7 over 4 to be 8 over 4. 8 over 4 is same thing as 2 pi because 8 divided by 4 is 2. Next. Here's the portion that maybe some of you just have to... Some of you can understand, some of you can understand, but by feeding the topic because we have to learn the special right triangle here. So this point here, remember the radius here is 1. So what is the coordinate of this point here? If the radius is 1, everything there measures equal to 1 from the center. So this one here is 1, 0. Okay, if that's 1, 0. On the other side, it will be negative 1, 0 because it's negative, right? From here to there, because you don't go left or right, you go up, that's going to be 0, positive 1. From here, 0, you don't go left or right, you just go down, so that's going to be 0, negative 1. Now, here's a portion now that I need you just to, just take it, okay? If it's over 6, here's my pattern. 6 is 3 times 2, so I'm going to put here square root of 3 over 2. And this is 1/2. It's always going to be like that, okay? Again, we skip a topic, which is special right triangle. That's why I'm just feeding this to you. Everything with over 6, like pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6, just write square of 3 over 2, 1/2, okay? I'm going to put here square of 3 over 2, 1/2, square root of 3 over 2, 1/2, square root of 3 over 2, 1/2. Clear? But there is an important thing that you need to know. This is a first quadrant. Remember, the unit circle is in a Cartesian plane. So this is a positive. The value of any point in the first quadrant is both positive. So this is positive square of 3. This is a positive square of 3 over 2, positive 1/2. When you go to the second quadrant, this point will be same numbers, square of 3 over 2, 1/2, but the x value is negative. That should be negative square of 3 over 2, comma 1/2. When you go to third quadrant, both of them has to be negative. This should be negative, that should be negative there. When you go to the fourth quadrant, the x value is still positive, but the 1/2 becomes negative. It's clear? So in the first quadrant, both of them are positive. In the second quadrant, the x value is negative and the y is positive. In the third quadrant, both of them are negative. And the fourth quadrant is positive, negative. Okay? All right, that's for the over 6. For the over 4, if here 3 times 2 is 6, for pi over 4 is square root of 2 over 2, square root of 2 over 2. If you notice, they're exactly the same digit. Square root of 2 over 2, square root of 2 over 2. And so meaning say same thing, everything with over 4 are going to be square root of 2 over 2. So here with 3 pi over 4 will be square root of 2 over 2, 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 and square root of 2 over 2, square root of 2 over 2. Sorry. And the sign remains the same. The sign, hold on. For the second quadrant, it will be negative, positive. So this is negative square root of 2 over 2 and square root of 2 positive 2. For the third quadrant, both of them are going to be negative. For the fourth quadrant, only the y value will be negative. Okay? Next, for the pi over 3, here's the technique. For the pi over 3, it's just the opposite of the over 6. 1 plus 2 is 3. So I'm going to start with 1 over 2 and then square root of 3 over 2. If you notice, this is just same thing as this, just transpose. The x becomes y, the y becomes x. And all over 3 will be the same thing. So 1/2 square root of 3 over 2, 1/2 square root of 3 over 2, 1/2 square root of 3 over 2. Okay, that's just my pattern. And then same thing, the sign follows. For the first quadrant, positive, positive. Here, the y value will be negative. Here, both of them will be negative. Here, only the x is positive and this is negative. There you go. That is your complete unit circle. And again, you can get the details of this anywhere. You can search for it. That's great. The question, do you know how to build? There you go. Do you know how to use this one is what we're going to learn. So some stuff that you need to know. Okay. Let's go here. First, I have a scratch paper here. Okay, I don't probably. So let's do it this way. Okay. Sorry, guys. Okay, so let's say you're given. Let's try. By now you should have learned already the 3 basic trigonometric ratios: the sine, cosine, and tangent. We know that sine tangent and cosine tangent are opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. But since we're dealing with unit circle, I don't know if you can see, I'm going to zoom it. Since we're dealing with unit circle, in unit circle, the hypotenuse is always equal to 1. Therefore, if that's equal to 1, the denominator here will be equal to 1. To make the story short here, I'm going to simplify it. Sine theta is whatever the y value. Cosine theta is whatever the x value. And the tangent theta, you divide the y over x. This is only true in a unit circle because the radius is equal to 1. So that's something that I would like you to write in your unit circle because it's a basic foundation here. Sine theta is y, cosine theta is x, and tangent theta is y over x. Okay? So I need you to write that down. Make sure you know that. Okay? And here's how you apply and solve trigonometric expression here. If I ask you, what is sine of, let's say, 240 degrees? What is sine 240? Look at your unit circle. Look for 240. 240 right there. See it? Now, 240. That's your 240. Now, if that's 240, the question is, what is sine? Sine is y. So whatever the y coordinate at 240, that will be the answer. So where's the 240? 240 is right here. What's the y value in the coordinate here? It's negative square of 3 over 2. So sine 240, the answer is negative square of 3 over 2. And that's the answer. Okay? One more. If I have cosine, let's say 5 pi over 3. Okay? So where's 5 pi over 3? 5 pi over 3 is right there. That's my 5 pi over 3. And the question is cosine. Cosine is x. So what's the x value at 5 pi over 3? Go to 5 pi over 3, look at the coordinates. What is the x value there? It's 1/2. So it's going to be equal to 1/2. That's the answer. Easy, right? Okay, let me give you a practice here. Here's a practice. I'd like you to pause and try it on your own and answer them based on your unit circle. Boom, there you go, very quick. Okay, sine 90. Let's look at your coordinate, your unit circle. Where's the 90 is right here. Sine is the y value. So therefore, what's the y value is here? 0, 1, xy. Y is equal to 1. Okay. Another way there is use your calculator. If you try to make sure the mode is in degree, which is in degree already for me, then sine 90, boom, is equal to 1. Easy. Okay. Cosine 30, if you do the cosine 30 or cosine 30, it's 0.8666. What's that number? We do not know. For us to know that one, go to the 30 degrees. Where's the 30 degrees? 30 degrees, 30. There's your 30 degrees. There's 30 degrees. What is the x value there? X value, because it's cosine, that's why it's x value. X value here is square root of 3 over 2. So the answer there is square root of 3 over 2. Clear? Okay. Tangent. Tangent is, remember, it's y over x. Okay. The question is 7 pi over 4. Where's the 7 pi over 4? 7 pi over 4 is right here. 7 pi over 4 is square root of 2 over 2, comma, negative square root of 2 over 2. Y over x. So you're going to divide negative square root of 2 over 2 by square root of 2 over 2. So this will be negative square root of 2 over 2 divided by square root of 2 over 2. They're the same digit except one is negative. So what this will cancel. What's negative 1 divided by 1? It's going to be just negative 1. Right? Very simple. Sine 2 pi. 2 pi is right here. Sine means y. What's the y value here? The y here is 0. 330 degrees. 330 degrees is right here. The question is cosine. What's the x value here? It's square root of 3 over 2. So square root of 3 over 2. And tangent 210. 210 is right there. 7 pi over 6 is y over x. So this will be negative 1/2 over negative square root of 3 over 2. Now, please focus here. It's basic algebra. First, both of the denominators are 2. I can cancel it. So I end up with negative 1 square root of 3. Negative square root of 3. Negative divided by negative is positive. So it's going to be 1 over square root of 3. Rationalization. Rationalization means it's a process wherein it eliminates the chance for you to have a square root or even root in your denominator. So you multiply each by square root of 3. So this will be 1 times square root of 3 is square root of 3. Square root of 3 times square root of 3 is square root of 9. But square root of 9 is just 3. So that's the tangent of 210. All right, there you go. I hope you guys learned something and you're able to build, construct a unit circle. You understand the pattern on how to build them again, identifying the coordinates for each of the special angles. Again, remember guys, there's a topic missed here, the special angles. So I just feed that to you. And next we have to know that in a unit circle, sine theta equals y, cosine theta equals x. Cosine tangent theta is y equals y over x. And for us to simplify it is finding the coordinates here. I hope you learned something. Kaboom!